guys, very good evening to all of you. Welcome to you all on the GATE Study 5 Plus. Can you please confirm audio and video so that we can start the session? So guys, as I told you, we are live. Right now we are having parallel stream. So can you please confirm guys, audio and video both clear? So let's start today's class. For today's class title is gain margin and phase margin. We will start the gain margin, phase margin. First of all, just let me know, am I audible? Clear? Audio video both clear? Mithun? We have noted that in yesterday's session, I think there was a lag, or even voice also mismatch. Mithun, is it correct, beta? So that is why today we are trying a different method. Okay, so different method we are using today for having live streaming at both ends. Can you please confirm today also, is there any mismatch in voice? Voice mismatch है क्या या कोई ज़्यादा lag है क्या? Today is also there is any mismatch. Yesterday we have seen that on YouTube also there is a voice mismatch. So guys, let's start today's class. First of all, tell me if you attended the last class, na? Just let me know. What was the last slide of last class, guys? Okay. I think all these questions we already completed. You can just confirm which was the last slide of last class. The last class we had a last discussion on resonant peak and resonant frequency, bandwidth, cutoff frequency. So these all slides we already completed till the last class. I think we have solved this. This was the last question of last slide. I think this was the last slide of the last class we have just this question. Okay. So today's class we are going to start with this GATE problem, not even engineering services, IES problem. Now sir, it's perfect. Yes, now it's perfect. No lag. Okay, very nice. And voice is also clear. Am I loud and clear, guys? Should I speak more loudly or it is okay? It is fine. Last class we had a last. Now it's perfect. Okay. This is also clear. Am I speak? It's fine. Oh, sorry, it's perfect. Fine, sir. Okay, fine. Now, student, this is the first question. We are going to start today's class with this engineering services problem, and very soon we will start the gain margin, phase margin. Okay. तो अभी तक की क्लास में हमने जो पढ़ा, as far as frequency domain is concerned, first we started with the LTI system with respect to sinusoidal input, and we have noted that whenever any sinusoidal input is applied to a system, the output is also sinusoidal, but having different magnitude and phase, and whereas frequency omega remains same, the magnitude will depend on the magnitude of transfer function at omega input will give you the A, and the angle of transfer function at omega input will give you the additional phi angle. Okay, and we have solved many gate problems in yesterday class. Now student, resonant peak, resonant frequency formula also in the yesterday class we derived first, and after that we have solved some problems also. So this question is also based on the same. A unity negative feedback system, it means here h of s equal to 1, and the transfer function is this. Examiner is asking for resonant peak, actually it is mr, okay, typing error here, and this is omega r, not omega m, r respectively. It means simple formula based question, straightforward question. Examiner directly asking the omega r and mr only. So first of all, can we write the characteristics equation? The characteristics equation we can easily write because of unity feedback system. The actual characteristics equation is 1 plus g of s h of s equal to 0. 1 plus g of s h of s equal to 0. This is the actual characteristics equation. But whenever we have a unity feedback, we have an advantage, and we can directly write d plus n equal to 0. We can directly write d plus n equal to 0. Tell me guys, once you will do d plus n, so don't you think you will get s square plus 6 of S and plus 25 equal to 0. Yes or no, guys? And if you will compare with the standard equation is nothing but S square plus twice zeta omega ns plus omega n square. Once you will compare with the standard equation, don't you think you will get omega n value 5 only? After comparison these two equations, so you should write here twice zeta omega n equal to 2 coefficient here. S coefficient is this, here S coefficient is 6. Substitute the value of omega n 5 to the 10. So don't you think zeta value 0.5, 0.6 only? Zeta value is 0.6, 5 to the 10, 6 by 10, 6 by 10.6, sir. Now we have omega n also, now we have zeta also. And do you know the MR formula? What is the MR formula, guys? So here when you will write the overall closed loop transfer function, tell me Mithun, if I will write closed loop transfer function, don't you think by CLTF closed loop transfer function n upon d plus n, so should I get 25 upon s square plus 6s plus 25. So tell me Mithun, what is, all of you guys, other students should also reply. Tell me, other students should also reply. What is the DC gain? What is the DC gain of this CLTF? What is the DC gain of this CLTF? 25. DC gain of CLTF is 1 only. It means the resonant peak formula shall be write 1 upon twice zeta root of 1 minus zeta square. This is the only MR formula we need to apply here. And we already have zeta value. So once you will put, you will get MR equal to 1 upon twice into zeta. Zeta is 0.6 under root of 1 minus 0.6 ka whole square. Just do some calculation, guys. I think once you will calculate now, should get MR is near to 1.04. Can you please confirm after calculation you are getting or not? Just use the calculator, square it, then after take the root, multiply with 0.5 and 2. Tell me what is the final answer. So I think 1.04 something you will get. It means two options we can eliminate here, A and C, either B correct or D correct. Okay, sir. First confirm this, you are getting MR or not. Then after that we'll find omega R also. Yes, better. Can you please confirm audio video again? MR 1.04, shabash, correct answer. MR is 1.04 only. And if I talk about omega R, what is omega R formula? Sir, omega R resonant frequency formula is omega n root of 1 minus 2 zeta square. So student, many few time directly straightforward formula based question came in the competition exam. Okay, अगर कभी direct formula based question आया है, then it is a gift for you. If you know the formula, just apply it. Make sure that you should not do silly mistake in the calculation. Okay, so this is one of the directly straightforward formula based question. You just need to identify zeta and omega n first after comparison, and once you will have omega n and zeta value, just put in the formula and you will get the answer. Don't you think omega n value is 5, sir? Yes, under root of 1 minus twice of theta is 0.6 ka whole square. Just calculate this, guys. Once you will overall calculate, now it should be around 2.67 radian per second. 2.67 radian per second. So that is why I think correct answer is B for Bangalore, guys. B for Bombay. Yes. Do it fast. Fast. calculate this, whether you are getting omega r 2.6 near to 2.6 or not, and just confirm. Okay guys, so I think you are calculating. Once you will complete, just do reply so that we can go for next. Is this completed? I think. Is this completed? So I think you are calculating. 2.67, shabash. So I think student already confirmed it is 2.67. Correct answer 2.67, option number B. Shall we go for next now? Okay. So now we should go for next, guys. The next question that has been asked in EE 2015. Question is saying that it is again a pure conceptual question. No formula is required here. Pure concept. Now student, basic concept पे based question है ये. Now just read the question. The transfer function of a second order system with a perfectly flat magnitude response of unity. It means the system is having a unity magnitude. It means the zeros and poles must be symmetrical with respect to the imaginary axis. Then only you will get the unity magnitude. I am giving you the example also. Suppose that we have a transfer function like this. Suppose that I have a pole at -1 and I have a 0 at +1. Then don't you think the transfer function should be s minus 1 upon s plus 1? Yes or no? So shall we say that here poles and zeros are symmetrical to each other, or having the mirror image with respect to this y-axis? This is your j omega axis and this is your sigma. I am just giving you example here. Whatever we are discussing here, this is example. Now tell me guys, this is my transfer function, sir. And don't you think in this transfer function, if I will find magnitude, then first I should write s equal to j omega minus 1 upon j omega plus 1. Bolo bhai, yes or no? Now tell me, what is the magnitude of this? What is the magnitude of this? The magnitude is nothing but under root of omega square plus 1 upon under root of omega square plus 1, and then only we will get the magnitude 1 or flat unity. So in short, अगर आपको unity magnitude चाहिए, then pole and zeros must be symmetrical with respect to imaginary axis. This is clear? Absolutely clear, sir. Now student, what examiner want here? Examiner has given one pole to us, and which is nothing but here. क्या पोल है वो? Okay, has a pole 2 minus 3j. अब देखो ये कॉम्प्लेक्स कॉन्जुगेट पोल है, ऐसा पोल कभी अकेला नहीं आता. Those poles are always travel in a conjugate. इसका मतलब सेकंड ऑर्डर सिस्टम है, दो पोल होंगे. तो पहला पोल बोल रहा है 2 माइनस का 3j, प्लस का 2 मतलब यहां कहीं होगा, बता देते हैं. प्लस का 2 मतलब सर यहां कहीं होगा. यस सर. प्लस 2 माइनस का 3j, प्लस 2 माइनस 3j मतलब यहां कहीं. इज इट माइनस 3j? यस सर, माइनस का. And if one pole is at 2 minus 3j, then its conjugate must be at plus 2 plus 3j. तो आया ना. तो इसका मतलब ट्रांसफर फंक्शन में दो पोल हैं, conjugate complex conjugate pole, and for this system we want to make the magnitude unity. We want a flat magnitude unity. So don't you think कि सर इस ट्रांसफर फंक्शन में जिसमें दो पोल हैं and we want to make the magnitude unity, then the two zeros must be symmetrical with respect to this imaginary axis. मतलब जो दो जीरो होने चाहिए ट्रांसफर फंक्शन में, it should be -2 plus 3j or -2 minus 3j. This is clear or not? Now students, just see the options. In which option? Here no zeros or origin, so wrong only. Now tell me, option number 2 plus minus का 3j pole which is given to us, and zeros lie at -2 plus minus का 3j. Option number D for Delhi is correct. Here no formula is required, only basic foundation concepts is required. Is it clear or not, Mithun? Are you getting this? I hope you are getting it. I hope you all guys getting this, yes or no? Done? So take your time and complete it fast. Once you will complete, just let me know guys. So that you will go for next. Are you getting this? Yes. So now take your time, complete it. Just try to make the beautiful classroom notes, guys. Okay, as I told multiple times, to make the classroom notes and clean. Okay. Is this completed? Shall we go for next or wait? Okay, I think wait. Once you will complete it, and next. Okay. Wait. Okay. Friends are writing wait, so we are waiting, guys. Once you will complete, we will go for next. So in this question, no special formula, guys. Basic concept, we want a flat magnitude unity and poles are given to us. Only one pole examiner provided. Other pole we can easily identify because it is conjugate in nature. And to make the magnitude response unity, poles and zero must be symmetrical with respect to y-axis. Okay, you can make a note also even. You can write a note also to make. You can make a note also. To make magnitude response of unity, poles and zeros must be symmetrical with respect to y-axis. In a transfer function, poles and zeros must be symmetrical with respect to y-axis. Just clear? I think it is clear. Poles and zeros must be symmetrical with respect to y-axis. Done, sir? So student, right now completed. Now we are going for next. Again a beautiful question, guys, here. Now this time read the question carefully. This is a 2 marks question. It deserves 2 marks actually. I think student right now, I think this smart board is lagging actually. So just allow me for 1 minute. I will just restart it. Okay. Okay. Okay, चलो अभी हम कर लेते हैं. Next session for this session we'll try to manage. Okay. The magnitude of the frequency response and underdamped second order. देखो यहाँ पे first statement that we should note underdamped second order system. Okay, underdamped means zeta greater than 0 less than 1. Now 5 at 0 radian per second and peak to 10 root 3 at 5 root 2 radian per second. So guys, don't you think, sir, if you will feel the diagram of this, you will feel the diagram. Tell me this time, examiner is given resonant peak value. What is resonant peak? Peaks to 10 by root 3 at 5 root 2. It means this is omega r and this is mr. And examiner has also given the magnitude at omega equal to 0. It is not 1, it is 5. In general, we know it is 5. In general, we know it is 1. So in the yesterday derivation, I hope you remember. So this is my omega r, guys. And this is my mr. So according to the question, the mr value is 10 by root 3. And according to the question, the omega r value is nothing but 5 root 2 radian per second. 5 root 2 radian per second. And omega equal to 0 पे 1 नहीं है, omega equal to 0 पे 5 है. It is given. So don't you think इसका मतलब k का value 5 है? It means DC gain of CLTF is 5. It means DC gain of closed loop transfer function is 5. Tell me yes or no. And because of this, your MR formula is what? Your MR formula in general is 1 upon twice zeta root of 1 minus zeta square. This formula is only valid if provided K value is 1. But this time K value is 5. So the formula should look like this. So MR formula will be what? So MR formula for this particular question will be twice of 5 upon twice zeta root of 1 minus zeta square. इन दिस क्वेश्चन, जब ये क्वेश्चन गेट में आया था तो मैक्सिमम स्टूडेंट ने क्या गलती किया, दे आर कंपेयरिंग एमआर विद द स्टैंडर्ड फॉर्मूला 1 अपॉन ट्वाइस जीटा रूट ऑफ 1 माइनस जीटा स्क्वायर. अगर आप उससे कंपेयर करोगे सो नो ऑप्शन विल सेटिस्फाई. इसका मतलब चारों में से एक भी ऑप्शन सेटिस्फाई नहीं करेगा और आपका टाइम भी वेस्ट हो जाएगा. अच्छा, आप एग्जामिनर क्या बोल रहा है, ओमेगा आर भी हमारे पास कंपेरिजन के लिए है, तो ओमेगा आर का फॉर्मूला एक बार लिख लेते हैं. ओमेगा आर इज नथिंग बट ओमेगा एन रूट ऑफ 1 माइनस 2 जीटा स्क्वायर. Now student, we need to choose one option out of 4 which satisfy MR and omega R value. Because by observing the options we can easily compare zeta and omega n. इसको हम स्टैंडर्ड ट्रांसफर फंक्शन से कंपेयर करके जीटा ओमेगा एन निकाल सकते हैं. एंड फॉर विच ऑप्शन जीटा एंड ओमेगा एन सेटिस्फाई MR एंड ओमेगा R वैल्यू which is given to us 10/√3 5/√3, that particular option correct. इसका मतलब आसान लैंग्वेज में हमको केवल वो ऑप्शन चूज करना है जो जिसका जीटा और ओमेगा एन इस फॉर्मुलेज में रखने पर हमको MR 10/√3 मिल जाए और ओमेगा R 5/√3 मिल जाए. जिस ऑप्शन में मिल जाएगा वो ऑप्शन करेक्ट है, आसान है. क्लियर है सर. नाउ स्टूडेंट टेल मी इफ आई विल कंपेयर ऑप्शन नंबर ए. थोड़ा सा यही पे स्पेस बनाता हूं आप लोगों के लिए तो अगर हमको बार बार आगे पीछे ना आना पड़े. ऑप्शन नंबर ए को कंपेयर करोगे आप k इंटू ओमेगा एन स्क्वायर अपॉन s square plus twice zeta omega ns plus omega n square. Need to compare like this. So k value anyway 5. So now 100. It means, don't you think after comparison we can say that omega n value is 10? Don't you think omega n value is 10? And here also we should write twice zeta omega n value is equal to 10. What is omega n? Omega n से 10 कट गया तो zeta value कितना आ गया? Zeta value half आ गया सर. Now guys tell me zeta value is half, omega n value is 10. Now only substitute the value here MR और omega R में. तो मैं MR के अंदर वैल्यू पुट कर रहा हूं, आप लोग भी साथ साथ पुट करिए. तो आपको मिलेगा 5 अपॉन ट्वाइस इन व्हाट इज जीटा वैल्यू. बड़े आराम से कर रहे हैं हम, आप लोग भी साथ साथ करिए. सो दैट नॉर्मल स्टूडेंट्स पहली बार पढ़ रहे हैं कंट्रोल सिस्टम, बिल्कुल अगर सेकंड ईयर में भी है थर्ड ईयर में भी है, आराम से आप समझ सकते हो. इफ यू कैन लिसन केयरफुली यू कैन अंडरस्टैंड. No one can stop you from the learning. केवल good intent होना चाहिए. You should be energetic enough. और तीसरा, if you are able to listen, you can understand. जो सुन सकता है शिद्दत से वो समझ सकता है. अब बताइए twice zeta root of 1 minus 2 zeta square. देखो ना यार, twice zeta 1 minus zeta square का मतलब क्या है? zeta का मतलब 1/2 का होल स्क्वायर 1/4 हो गया सर. 2 कट गया सर. तो MR कितना आ गया सर? MR आ गया 5 अपॉन अंडर रूट ऑफ 4 minus 1 मतलब 3/4 आया क्या? अब बताओ क्या ये 5 इंटू रूट 4 अपॉन रूट 3 आया क्या? और रूट 4 क्या होता है? 2 होता है. तो क्या 5 2 जा 10 अपॉन रूट 3 आया क्या? देखो रेजोनेंट पीक आ गया 10 अपॉन रूट 3 और जो कि ऑप्शन नंबर ए सेटिस्फाई कर रहा है. मतलब अभी तक हमने केवल MR चेक किया बाय द वे, और ये वाले MR ने मतलब जीटा और ओमेगा एन ने आपको 10/√3 MR लाके दे दिया. इट मींस द जीटा एंड ओमेगा एन वैल्यू व्हेन आई विल कंपेयर विद द ऑप्शन ए. And if I will put this value in this formula, I got exactly MR which is given to us. It means this is option number A satisfied MR. If option number A also satisfy omega R, then for sure option number A is correct only. Is it clear? Now let me check omega R also. Okay, I will use the next slide for omega R calculation. Don't have that space. So omega R value is nothing but omega n root of 1 minus twice zeta square. And do you know what is omega n in the last? Omega n is 10 sir. Omega n is 10 and root of 1 minus twice zeta square 1/2 का whole square, so 1/4. So shall we write omega R is nothing but 10 into root of 1 minus 2 2 ja 4. So is it 1/2? So shall we write 10? 1 minus half is half only. So is it half? So shall we write guys 10 into, बोलो, here is root 2 ना, So if I will multiply with root 2 and divide with root 2, so don't you think it will be tan upon 2 into root 2? So it will give you 2 5 are 10, so it will be 5 root 2. Is it 5 root 2, guys? Is this 5 root 2 correct, guys? 5 root 2. It means, sir, हमारा omega r कितना आया? Sir, और omega r value is nothing but 5 root 2. और omega r value is nothing but, or omega r value is nothing but 5 root 2. Because by comparing option number A, we got some zeta value, we got some omega n value, and by using those zeta and omega n value, we are getting exactly mr and omega r same to same, which is given by the examiner. क्या हो गया बच्चों? Is there any lag क्या? Is there any lag or everything fine? I can see here some lag actually. I can see here some lag. Tell me, guys, is this clear? Mithun, are you getting or not? All of you should reply, na? YouTube also students can reply. Right now is clear or not? So now complete this, guys. Option number A only satisfy. If you will check the other options, for the other options, zeta and omega n value does not satisfy the mr and omega r which is given to us. It means correct answer option number A for Ahmedabad only. Clear, sir? Okay. So now, guys, note down fast. I'm just waiting for you. Once you will complete, just let me know. So take your time, write the given data which is available in the question. In your classroom notes, first of all, you should note down the given data and then followed by the solution and correct option only. No need to write all the options, you can write directly correct option. Okay, I think you are writing. I am giving you time for writing, guys. So everyone do reply. Shall we go for next or wait? We go for next now. I think now it's completed. So shall I show you next slide? Omega are actually in the next slide. Done? Chill. So now complete this slide also. Complete this calculation part. And after that, we will start the concept gain margin and phase margin. Okay. After that, we'll start the gain margin, phase margin, which is the actual title of today's class. Okay. बताइए Done. Shall we go for next now? I think now done, completed. Yes. Actually, this is completed. I think done now. Completed. Okay. Now, student, make a heading. Stability from frequency response plot. So we will discuss 4 criteria: phase crossover frequency, gain crossover frequency, gain margin, and phase margin, and all we can generate from the characteristics equation. It means characteristics equation provide us the closed loop poles. It means, guys, these all the parameters will provide you the stability of a closed loop system, because in the control system we are looking for the stability of a closed loop system, and closed loop stability is defined by the closed loop pole, and closed loop pole provided by the characteristics equation of a control. So from this point, can we write this point, guys? GSHS is nothing but what? What is GSHS from here? What is GSHS from here? Once you will shift 1 that side, then you will get -1 plus J0. GSHS equal to -1 plus J0. So don't you think this point is nothing but critical point, guys? Don't you think this point is nothing but critical point only? Yes or no? -1 plus J0, critical point. So remember this. GSHS equal to -1 plus J0 is working as a critical point. When we will discuss polar plot, okay, Nyquist plot, always we need to refer this point as a critical point, and we will find the stability of a closed loop system by using the gain margin, or by using phase margin, by using polar plot, Nyquist plot, with respect to this critical point, with respect to the critical point, which is -1 plus J0. Okay, bachcho? Note down fast. Note down. Now, student, we will write one by one. I think this is completed parallelly. Only 2 equations you need to write. So I am going to next slide. Still, if you want, you can just write. Otherwise, I think it is okay only. So now we should write the first statement you should write, guys. Gain crossover frequency. Gain crossover frequency. Gain crossover frequency, which is nothing but omega GC na. So gain crossover frequency is nothing but, sir, omega GC. So you should write a statement here. It is a frequency. It is a frequency at which it is a frequency at which the magnitude at which the mode of GSHS, or we can say that we all know that in the frequency domain the first step is always S equal to J omega. So the magnitude of G J omega H J omega is equal to 1, is equal to either 1, or if you wish to find dB of 1 ना, 1 का dB निकालोगे तो dB कैसे निकालते हैं? dB निकालते हैं सर 20 log 10 1, you will get 0 dB. Yes or no? So you should write 1 or 0 dB. So this is by the definition we can write the gain crossover frequency, which is omega GC, is nothing but a frequency at which the mode of GSHS or mode of GJ omega HJ omega is equal to 1. So how to write? As in the form of equation, we should write like this. Mode of GSHS, sir, mode of GSHS, or we should write mode of GJ omega HJ omega at omega equal to omega GC is equal to 1. So this box is important. This is very much important formula. So as far as first formula is concerned, omega GC वो frequency है जहाँ mode of GSHS 1 हो जाए आसान लैंग्वेज में. It is a frequency at which the magnitude of GSHS or mode of GJ omega HJ omega is equal to 1. I think it is also noted. I think you guys completed with this. Shall we go for next now? So next definition, this is the first parameter, first stability parameter. So gain crossover frequency. Second, we should write phase crossover frequency. Okay. Second, we should write, guys, phase crossover frequency. We are writing here second, phase crossover frequency. But first of all, you should tell me, is it completed kya? Is this completed? First one is completed, then we'll go for next now. I think this one is completed. Done. You can also reply parallelly. Done, sir. Okay. So now omega PC we should write. Omega PC. What is omega PC, guys? Just note down fast. Okay. So write omega PC. Hello. Yes, guys. So sorry for the interrupt. I think this is clear now. Am I audible now? Audio clear, guys? Sorry for the interrupt. Now, omega PC you should write, guys. It is a frequency at which, okay, you should write the language part. It is a frequency at which the angle of GJ omega HJ omega or angle of GSHS at omega equal to omega PC is equal to minus 180 degrees. Write this. It is a frequency at which the angle of GJ omega HJ omega, it is a frequency at which the angle of GJ omega HJ omega, it is a frequency at which the angle of GSHS or the angle of GJ omega HJ omega at omega PC equal to minus 180 degree. Is it clear, beta? Yes, all of you? So you can also note down it is a frequency at which the angle of GSHS or the angle of GG omega HG omega is equal to minus 180 degree. The frequency is known as omega PC. Now we should write the next parameter, which is, guys, gain margin. You should write the gain margin. Write a statement. It is a parameter. Write a statement. We are writing in the gain margin now. Okay. So write a statement. It is a parameter that measure. We are writing about gain margin. Okay. It is a parameter. It is a parameter which measure how much relative gain variation. How much relative gain variations. How much relative gain variations are needed, how much relative gain variations are needed at omega PC to lose the stability. I am again repeating, gain margin is a parameter. It is a parameter. We are writing in gain margin. It is a parameter. I will repeat 3 times, guys. You can write easily. Okay, still if you want, I will again repeat. Okay, it is a time required for the, or sorry, not it is time. We are writing in the gain margin. So it is a parameter. Gain margin is a parameter that measure how much relative gain variations, are needed at omega PC, to lose the stability. I will explain you this statement. First we will write how to find the gain margin. So first step we should follow the magnitude of GJ omega HJ omega, the magnitude of GJ omega HJ omega at omega equal to omega PC gives you X, and the gain margin is nothing but 1 by X, and the dB value, gain margin in dB, is nothing but 20 log 10 X, 20 log 10 XC. So this is your gain margin. This is your gain margin. Is this crystal clear, प्यारे बच्चों? I hope this is crystal clear. So magnitude of GSHS at omega PC equal to X. So gain margin will be 1 by X, and gain margin in dB is nothing but 20 log 10 1 by X. 20 log 10 1 by X. This is fine, बच्चों. So now students, suppose that कि अगर gain margin का value, suppose करो gain margin value is plus 20 dB. I am taking the example. So as far as the definition is concerned, gain margin is a parameter that measure how much relative gain variations are needed to lose the stability. So if the gain margin is plus 20 dB, then we will say कि plus 20 dB variations are required to lose the stability. And who can lose the stability? If the system is stable, then only it can lose the stability. Bolo yes or no? So it means once the gain margin is positive, then your closed loop system is stable only, because then 20 dB. If gain margin is plus 20 dB, it means the closed loop system is stable, because 20 dB gain variations are needed to lose the stability. Is it clear? Now, if the gain margin is, suppose that gain margin is minus 10 dB, then our language is, then gain margin is minus 10 dB. It means 10 dB gain variations are needed to achieve the stability, or to, we can say that, to gain the stability. Yes or no? So it means whenever gain margin is positive, we can write in short, whenever gain margin in dB is positive, then the system is stable, and whenever the gain margin in dB and negative, then the system is, and when we are talking about system, it means by default कौन से system की बात हो रही है? By default closed loop system की बात हो रही है, because all the parameters GM, PM, omega GC, omega PC are defining the stability of a closed loop system, or are used to calculate the stability of a closed loop system. Is it clear? So if the gain margin is minus 10 dB, then 10 dB gain variations are required to achieve the stability. And if the gain margin is 0 dB, if the gain margin is 0 dB, then this is the case of marginally stable. Now suppose that, guys, we have a system that is having the gain margin 20 dB. After that, gain margin is decreasing 20 dB to 15 dB, then 10 dB, then 5 dB, then 2 dB, then 0 dB. So don't you think your relative stability going to decrease? बोलो, अगर गेन मार्जिन पहले 20 dB था तो सिस्टम रिलेटिव स्टेबल ज्यादा था, फिर जब 10 dB हो गया तो रिलेटिवली कम स्टेबल हो गया. आर यू गेटिंग माय पॉइंट? So if the gain margin is decreasing, then your relative stability also going to be decreases. And once the gain margin is zero, marginally stable, and once the gain margin is negative, system will become unstable. Closed loop system will become unstable only. I hope this is crystal clear. Just note down fast. All of you guys just note down fast. Done? Is it completed, beta? Shall we go for next? I think you just replied done. Now we should write the next, that is phase margin. Now we should write the next, that is phase margin. Now guys, note down fast, phase margin. To write here, it is a parameter which measure, again the definition is same, only the gain variation has been changed to phase variation and omega PC has been changed to omega GC. So now we are writing, it is a parameter, we are writing about phase margin. It is a parameter that measure how much relative, it is a parameter that measure how much relative phase variations are needed to lose the stability at omega GC this time. Okay, so I am again repeating, phase margin. It is a parameter that measure how much relative phase variations are needed, at omega GC, omega GC मतलब gain crossover frequency, to lose the stability. To find the phase margin, we have to follow the 3 steps. The first step is we have to find the angle of GJ omega HJ omega, at omega equal to omega GC will give you phi, and the phase margin is nothing but 180 degree plus phi. Phase margin is nothing but 180 plus phi. Where what is omega GC? Now student, first of all, you should be comfortable with all the 4 parameters. We have to take the quick revision also. Omega GC क्या था? Omega GC वो frequency था जहाँ mode of GSHS 1 हो गया था. So omega GC is a frequency at which mode of GJ omega HJ omega 1. Omega PC is a frequency at which angle of GSHS equal to -180 or angle of GJ omega HJ omega -180. What is the gain margin? Gain margin, magnitude of GJ omega HJ omega at omega PC will give you as gain margin 1 by x, and in the dB 20 log 10 1 by x. Phase margin calculation, angle of GJ omega HJ omega at omega GC will give you phi, and phase margin is 180 plus phi. Is this clear or not, beta? I hope this is crystal clear. Clear, bachcho, clear? Shall we go for next or wait? Completed, I think. Completed, yes. So now student, we will follow this, but before that we will make this table. What is the agenda to make this table? Why we want to make this table here? Because whenever any statement question will come now, we will prove this table when I will start the polar plot. When we will discuss the Bode plot, then we will prove this table as well. But whatever we noted till now, for the to make the closed loop system stable, or gain margin, phase margin must be positive. So if I talk about the phase margin definition again, suppose that phase margin is 30 degree. Suppose that phase margin is 30 degree, it means 30-degree phase variations are needed to lose the stability. 30-degree phase variations are needed to lose the stability. It means as of now my system is stable, and after 30-degree variation my system will become unstable. It means if my phase margin is decreasing from 30-degree, then 20-degree, then 10-degree, 5-degree, 0-degree, then actually my relative stability going to be decreases. मेरा system का relative stability decrease हो रहा है, and once the phase margin, so right now here the system is closed loop system is stable only, and once the phase margin is 0-degree, then the system is marginally stable only, and once the phase margin, suppose that minus 10-degree, then it will make the system unstable. I hope it is clear. So GM and PM are the parameter which help us to define the stability of a closed loop system. Is this clear, beta? Again there is a stuck, I think. So Mithun, all of you guys do reply fast. All the other students should also reply. Is there any lag or everything fine? Tell me guys. Is there any lag or anything fine? As far as yesterday class is concerned, today's class is better, or here also the same thing is going on? I think video stuck, huh? Clear, sir? Clear? So I think you noted all the 4 parameters. Now we should go for the table. So to make the system stable, gain margin and phase margin must be positive. Gain margin and phase margin must be, and when we are talking about this, we are always talking about the closed loop stability criteria for which system? For closed loop system. And this table is true only if it is provided the OLTF GS, the OLTF G of S, the OLTF G of S is stable. Stable means the open loop transfer function poles are must be in the LHS, must be. So we are assuming that open loop transfer function is stable. So this table will give you the stability of a closed loop system. If the gain margin and phase margin both are positive, if the gain margin and phase margin both are positive, it is in dB and it is in degree. It is in degree. Then we can say that omega GC must be less than omega PC, and it will make the system stable only. Yes, sir. If we talk about system is marginally stable, then the system will be gain margin must be 0 dB and the phase margin must be 0-degree. So gain margin 0 dB, phase margin 0-degree. It means your omega GC must be equal to omega PC. Omega GC must be equal to omega PC. And if I talk about system unstable, then your GM must be negative or your PM must be negative. So GM PM negative, then your omega GC is greater than omega PC, and it will make the system unstable. तो ये जो लास्ट कॉलम हम लिख रहे हैं ना, ओमेगा जीसी एंड पीसी रिलेशन, दैट वी विल प्रूव. दिस कंप्लीट टेबल आई विल प्रूव व्हेन आई विल टीच यू पोलर प्लॉट. When I will teach you Bode plot, we will prove that, and we will hence prove this table. Why we are why we are discussing this table right now? Because if the statement question will come now, then you can easily identify when GM0, PM0 system marginally stable, when omega GC less than omega PC, closed loop system stable, when omega GC greater than omega PC, the system going to be unstable. Fine, absolutely fine. Okay, Mithun, very good. Just complete this part, just complete this table part, so that we'll go for the first. We will do a small derivation for the standard second order system in this session, and after that, in the next session, we will continue the GM PM topic only. The next session will start around 9 o'clock. Okay, we will start the next session around 9 o'clock, 9 to 10:30. Again, we have the class, second session. First, you should complete this, and once you will complete, you should reply fast, so that we'll go for next. Shall we go for next now? I think it is completed. So now student, make a heading. Okay, first we should solve this question. In the feedback system shown below, this is my G of S value given to us, and in this diagram, once you will see K and GS here, so both should be in the cascade. What is OLTF? Don't you think your OLTF is nothing but, K upon S plus 1 into S plus 2 into S plus 3. This is your K, guys. Is it clear or not? Sorry, this is your open loop transfer function. So whenever two blocks are in cascade in the forward path parameter, we should take multiplication. So we should take the product. So यहाँ आ गया OLTF K upon S plus 1, S plus 2, S plus 3. Our examiner is asking the positive value of gain K for which the gain margin of the loop is exactly 0 dB and the phase margin of the loop is exactly 0. It means it is not a frequency domain question. Just read the question carefully. Don't you think by observing this, ये जो statement लिखा है gain margin 0 and phase margin 0, it means the system is GM 0, PM 0, system is marginally stable, and examiner is asking for the value of gain K. Don't you think examiner is asking for Km? Examiner Km का value पूछ रहा है. Or for the Km calculation, no need to use frequency domain. Don't you think by using the Raut-Hurwitz, we should write the characteristics equation, make the Raut-Hurwitz, and we will simply write Km. We will simply find Km. And even we can note down, sir, highest power is cube only. So no need to construct the Raut table. We will directly use BC equal to AD, and BC equal to AD means Km we will get, and will make the system marginally stable. Shabas. So just do 1 plus GSHS. So once you will write the characteristics equation, it will give you D plus N. Characteristics equation is what? D plus N equal to 0. Whenever unity feedback, D plus N. So it means just multiply this. So you will get actually S square plus, is it 3S plus 2? S square plus 3S plus 2 into S plus 3 into S plus 3 plus K equal to 0. Now student, tell me, once you will open the bracket, then you will get S cube plus 3S square. देखो ना, S cube plus 3S square plus again, is it 3S square again, and it is 3 3 ja 9S plus again 2S and plus 3 2 ja 6 plus K equal to 0. Just clear. Now tell me guys, what is the next? Is it S cube plus 3S and 3S will become 6S square plus 9S plus 2S will become 11S and plus 6 plus K equal to 0. I hope this is crystal clear, प्यारे बच्चों. Yes or no? Now tell me student, don't you think we should write BC equal to AD means, BC equal to AD means 11 6 is 66 equal to 6 plus K. What is K from here? Don't you think from here K equal to 60 only? This is the value of Km. Km value, it is a value of K which will make the closed loop pole on the imaginary axis and will make the system marginally stable. So इसका मतलब यहाँ पे जो फाइनल आंसर आपको टाइप करना था, NAT क्वेश्चन है 60. करेक्ट आंसर 60 आ रहा है. शाबाश बच्चों, शाबाश, वेरी गुड. I think you already replied. Very nice. So now we should go for next. Shall we go for next? चले हम आगे. चलिए. So next here is language guys. Which of the following statement is correct? Follow. Which of the following? Phase margin is always positive for stable feedback system. Phase margin is always negative for stable feedback system. Phase margin can be negative or phase margin or positive for the stable feedback system. None of the above. Come on guys, tell me. If it is a MCQ, then tell me. Phase margin always positive for the stable system. Is it option number A correct guys? Phase margin and GM must be positive to make the system stable. Is it clear or not? Is this clear or not beta? Yes or no? चलो आगे चलते हैं. स्टेटमेंट वाला क्वेश्चन था ये. तो again the conceptual question. The loop gain function LS of a control system with unity feedback. It means this is your open loop transfer function given to you, and if the gain crossover frequency, of the loop gain is less than the phase crossover frequency, it It means examiner is asking omega GC less than omega PC. ओमेगा जीसी लेस देन ओमेगा पीसी, जरा टेबल देखो, उस टेबल के अंदर फर्स्ट रो में लास्ट कॉलम में लिखा था, फर्स्ट रो लास्ट कॉलम, ओमेगा जीसी लेस देन ओमेगा पीसी. Whenever omega GC less than omega PC, then only GM PM positive and will make the system stable. Make the system stable. Yes sir. It means कि यहाँ पे क्या आपको ये पूछ रहा है कि सिस्टम क्या होगा, तो फटाफट बता दो यार. If omega GC less than omega PC, स्टेटमेंट क्वेश्चन है ना, no need to calculate. Is it system stable? Is it system stable means correct answer option number D for Delhi only. Correct answer D for Delhi. Correct answer D for Delhi. चलिए then next आसान question. Now student here also consider the following statement: the gain margin, phase margin of an unstable system may respectively be both negative. Is it 3 only? GM PM must be negative to make the system unstable in general. Whenever we are talking about in general, then these are all the problems we are commenting on the basic concept. The basic concept says that the GM PM must be positive, and by default we are provided that OLTF is stable. By nature OLTF, whatever GS, this is stable. Then only this is satisfied. Negative means 3 only, guys. Tell me yes or no. To make the system unstable, na, examiner is asking unstable only. Is it clear, bachcho? Shall we go for next or wait? So now we should go for next. Still, if you want time, guys, you can reply so that I will show you the last slide also again. Now just make a heading GM and PM for a second order system. Now guys, make a heading GM and PM for a second order system. Okay. I want here some extra slides. So we'll add here extra slide, no problem. So first of all, student, I will make this is your standard second order system closed loop transfer function. Standard SOS. Standard SOS. So no. SOS CLTF closed loop transfer. Now we are looking for the GM and PM for the second order system. So I will make the closed loop system diagram first of all for you. So this is my plus minus. This is my standard second order system. I will draw first standard second order system. So we should write here omega n square upon s into s plus twice zeta omega n, and here we should write r of s, and here we should write c of s, and this is nothing but h of s equal to 1, which is given to us. Now student, tell me what is g of s, h of s here. So the g of s, h of s is nothing but omega n square upon s into s plus twice zeta omega n. We will do a small derivation. As far as GM PM calculation is concerned, always we need to follow 3 steps for all the question. चाहे कोई भी क्वेश्चन आ जाए GM PM का, सबसे पहले आपको 3 स्टेप लिख देना है. अभी भी हम GM PM निकालना चाहते हैं. So for the second order system standard second order system, we will do a small derivation. So in the derivation also we should follow the 3 steps. What is the first step? So first step is always s equal to j omega. So substitute j omega in the transfer function. Substitute j omega in the transfer function. So if I will write the step number 1, that is gj omega hj omega. What is gj omega hj omega? Sir, here in this transfer function, wherever is s, you need to put s equal to j omega. So shall we write omega n square upon, in place of s, shall we write j omega plus j omega plus twice zeta omega n. Is it clear? Is it my equation number 1? Now tell me guys, next is what? Next is magnitude of gj omega and hj omega. What is the magnitude? So the numerator magnitude is omega n square only upon here omega and under root of, tell me, imaginary part square and real part square, it should be omega square plus 4 zeta square omega n square. Is it equation number 2, guys? Is this your equation number 2? Simply we calculated magnitude only, yes. Now tell me what is the angle of gj omega, guys? The angle of gj omega, hj omega is nothing but the angle of numerator 0. The angle of j omega is nothing but minus 90 degree. And here the angle is, the angle of j omega 90. When it will shift in the numerator, it will become minus 90. What is the angle of j omega plus this? So the angle is tan inverse omega upon 2 zeta omega, and in denominator So when you will shift the angle in numerator, then sign will change. So we should write minus का tan inverse, minus का tan inverse imaginary upon real, that is omega upon twice zeta omega n. Question number 3 only. So as far as GM, PM, any calculation is concerned, always we should follow the 3 step by default. तो ये 3 स्टेप तो आपको लिखना ही है, हमने लिख दिया सर फटाफट से, है ना. बीच बीच में आप लोग ऐसे इमोजी बना सकते हो बच्चों. आर यू गेटिंग और नॉट? यू कैन यूज द इमोजी एज वेल. तो इस तरह से इमोजी बनाने का ऑप्शन आ रहा है क्या आपको? सो दैट आई कैन एश्योर दैट यू आर गेटिंग. बोलो, इज इट क्लियर? चलिए, so now tell me, minus 90 degree minus tan inverse omega by 2. So equation number 1, 2, 3 we noted, sir. Now student, don't you think before calculating, if I wish to calculate GM, then first I should have omega PC, because gain margin definition is what? How many steps we need to find to follow to find gain margin? To find the gain margin, first we should have omega PC. And what is omega PC? Omega PC is a frequency at which the angle of GJ omega will become minus 180. Is it clear? Is this clear? Now tell me guys, sir, if I am looking for omega PC, then omega PC is a frequency at which this angle equation should equate to minus 180 degree. Already the angle equation we have here minus 90 degree. Now we need to choose that value of omega which will make this entire angle 90. क्योंकि अगर कैसे भी ये 90 हो जाए, if somehow I manage to make this term 90, then minus 90 will become minus 180. And my purpose will solve because I will get the omega PC. Omega PC is a frequency at which the angle is minus 180. Are bolo yes or no? Are you getting or not? Are you getting? Are you with me? Now tell me, कि sir here zeta and omega are the constants, so omega can only in our hand. So tan inverse infinity. Tan inverse infinity is only 90. Tan inverse infinity तो 90 डिग्री होता है. तो tan inverse infinity मतलब यहाँ से omega PC कितना आ गया? Omega PC is infinity radian per second. Omega PC infinity आ गया. Once you will put omega infinity here now, then only this term will give you 90. Minus 90 will become minus 180, because at omega PC your angle of GJ omega, HJ omega will become minus 180 degree. So now we already got omega PC. We are clear with the omega PC now. Now we got omega PC guys. Omega PC we got already. Yes, omega PC infinity. So we need to follow 2 steps to find gain margin. First is magnitude of GJ omega HJ omega at omega PC provide us X and gain margin is 1 by X. So it means first, don't you think I should do this? तो मैं यहीं पे कर देता हूँ. Magnitude of GJ omega HJ omega at omega PC. कितना आया omega PC का वैल्यू? Infinity. And where is the magnitude? सर देखो ये रहा magnitude, ये रहा. Is it our magnitude guys? Is this our magnitude equation? Yes or no? Yes. यही तो है magnitude. और इस magnitude equation में in place of omega, if I will replace omega PC in the magnitude equation, if I will replace omega with omega PC, then the magnitude should be equal to X. Margin is 1 by X. Yes or no? So don't you think omega PC value is infinity here? So in place of omega, मतलब यहाँ once you will put infinity here, omega is dominating in denominator. Omega is dominating in denominator. So hence you will put infinity into something, something upon infinity 0. Omega n square upon infinity 0. It means क्या ये वैल्यू 0 आ गया after putting here infinity. मैं डायरेक्ट लिख रहा हूँ इक्वेशन. इस इक्वेशन में ओमेगा की जगह इंफिनिटी पुट करने पे समथिंग अपॉन इंफिनिटी 0 आया है, एंड विच इज नथिंग बट x. हो which is nothing but x guys. Are you getting my point? And do you know guys, gain margin is nothing but 1 by x. Gain margin is 1 by x. Oh मजा आ गया. Gain margin 1 by x. X value 0 है. X value 0, gain margin 1 by 0. It means infinity. Is it gain margin infinity आया student? Is this gain margin infinity? Is this gain margin infinity? इसका मतलब ये कि सर for the standard second order system gain margin always infinity. Yes, the standard second order system which will satisfy the standard omega n square वाला term. तो हमारा सेकेंड ऑर्डर सिस्टम अगर स्टैंडर्ड इक्वेशन को फॉलो करेगा तो सेकेंड ऑर्डर सिस्टम का गेन मार्जिन हमेशा इंफिनिटी होगा, और गेन मार्जिन का सेकेंड ऑर्डर सिस्टम का फेज क्रॉसओवर फ्रीक्वेंसी भी इंफिनिटी होगा. So for the standard second order system, omega PC should be always infinity and GM value should also infinity. Gain margin value should also infinity. I hope it is clear. So this is your conclusion. So for the second order system, the omega PC value is nothing but infinity radian per second and the gain margin. So we got gain margin infinity now. We got gain margin infinity, and if you will take the dB value of this, the 20 log infinity is nothing but infinity dB only. So it means gain margin is nothing but infinity. So gain margin is nothing but infinity dB also. So this is the important note for the standard second order system. The standard result you should note down, second order system. Make it fast guys, make it fast. So in the next session we will continue the GM PM topic only. So right now in this session we completed with the GM part. So the phase margin of the second order system will start in the next session. That we will start at 9 o'clock. आज ही क्लास होगा 9 to 10:30. Okay, चलिए बच्चों. So I hope this is clear. बोलो. I think shall we? I think I need to show you this slide now. Note down fast. Note down fast, guys. This you should complete fast. After that, do reply. Once you will complete, just let me know so that we will go for next. Okay. So you guys can also reply. Yesterday also we did the pedal streaming. So tell me, yesterday method is good or today's method is okay? So today whatever technology we are using, that is fine, or yesterday wala? Bolo. Whatever today's method is we are using, that is fine, or yesterday wala? Bolo. Yesterday वाले में थोड़ा सा वॉइस मिसमैच हो रहा था, मैंने नोट डाउन किया था. आई थिंक फॉर टुडे सेशन वॉइस मिसमैच तो नहीं हो रहा है, लेकिन इज देयर एनी अदर प्रॉब्लम देयर यू आर फेसिंग? रिप्लाई कर दो सो दैट वी शुड टेक केयर दिस इन द नेक्स्ट क्लास. बोलो. चलिए, आई थिंक दिस पार्ट इज कंप्लीटेड. Shall we go for next or wait guys? Okay. So I think guys that's all from today's class. Today's this session. We will meet again after 30 minutes. Okay. We'll have a break of 30 minutes. We'll meet again. Is this completed, beta? Shall we go for next? All of you do reply. So I think now it's completed. Box is working. Yes, yes. So in today's chat box is like that. Otherwise, which you will prefer, yesterday approach or today's approach? Tell me guys. So you will conduct the next session in the same way, whatever you want. In the yesterday there is some lag problem. I think chat problem is manageable. 30 seconds you can wait. Yes. Follow. Okay, प्यारे बच्चों. So that's all from today's class. Bye bye. Take care, and we will meet again. We will continue this topic only. Okay. So this slide only will continue. We'll continue from this slide only in the next session. You can reply. Is this fine? So again, I think we need to wait for 30-second time to write in chat. Okay, okay. Now I'm getting you.